Right, for example 3, I'm going to draw a circle centered at the origin with a radius of 1. So basically drawing the unit circle. All right, we see there's a typo in here. So find the volume of the solid whose base is enclosed by this unit circle and whose cross sections taken perpendicular to this should be x-axis, are semicircles. So right here that identifies the formula. Cross sections, okay, perpendicular to the x-axis. So a to b, a of x dx. The area of the face is a semicircle. So half of pi r squared. Okay, and what we're going to need to know is what the radius is. So we have a little bit of work to do over here for our circle. All right, so this is our circle centered at the origin with a radius of 1. Okay, and our cross sections are going to be perpendicular to the x-axis, so that means we're going to put in this little strip here. Ugh. Okay, and then this strip would be more narrow, and this would be shorter. Okay, and all these are going to be cross sections. So I think this is actually going to end up being like a hemisphere. Okay, something like that. All right, so we need to know what the radius is. Well, the radius is going to be half of the diameter, and we can go from top to bottom and get the diameter. So I'm going to have to divide that by 2 to get the radius. So the radius is going to be half the diameter. First thing we need to do is solve this for y in terms of x. I might do a little bit of work over here. Extract the roots. And I think we've talked about this, that you have to have a positive and a negative root to get the top half of the circle and the bottom half of the circle. All right, so the top half of the circle is going to be the positive root, and the bottom half of the circle down here, this is going to fall along the negative root. So the diameter is going to be, okay, the top y, which is the positive root, minus the bottom y, which is the negative root. All right, these are going to make pluses here, so when I find the diameter, it's actually 2 of these roots, and that kind of makes sense. So that's the diameter. So remember, the radius is going to be half the diameter. So nice, these 2 will cancel, so the radius is going to be just 1 of the roots. So we're going to dump this back in here for r, and then dump all this back in here. Our limits, well, think of this as your unit circle. Left x is -1, right x is 1. My strips won't go to the left of -1, nor will they go to the right of +1. Okay, I'm going to pull the pi over 2 out as a constant multiplier, and I'll just be left to square the radius. And here's the radius. Okay, I think we can do this one by hand. I think there's a lot of space for us to do that. Okay, cleaning it up, I'm going to pull the pi over 2 out front, squaring a square root. Okay, I think I can go to the right a little bit. Antiderivative, x minus x cubed divided by 3, evaluated from -1 to 1. Okay, plug in 1 minus a third, minus, plug in -1, so that's -1. -1 cubed is -1, but I still have this minus, so that's going to be plus 1/3. Before I get any common denominators or anything, I'll probably just distribute. So 1 minus a third. Distributing here is plus 1 minus a third. So 1 plus 1 is 2. 2 minus 2/3. All right, common denominator, that would get us to 6/3. So this becomes 4/3. So pi over 2 times 4/3. One more thing to cancel a 2 out, divide a 2 out. Final answer, 2 pi over 3. we're going to take a look at example 4. We need to get a picture there so we can work off of that. All right, we've got the x-axis right here. X equals 3. This is y equals 0. And the y equals square root of x. Okay, so now we have a revolution or rotation problem. So we're going to rotate around the x-axis. Okay, so now that we know what we're rotating around, this horizontal line, we're going to put in here a vertical rectangle. Anywhere you want, doesn't matter. You can put several in there. Okay, but we're going to rotate around this way. Notice there's no gap between the bottoms of every single one of these rectangles that you're placing in here. There's no gap as you swing it around. There's not going to be a hole. So you might want to just put a note to yourself over here. This is going to be the disc method. Okay, with respect to x. So pi r squared h. I don't know where everything's going. All right, your left x is 0, your right x is 3. Okay, the radius of all of those little cylinders, those slices, is going to be the top y minus the bottom y. Square root of x minus 0. All right, so this is disk. No gaps. This is supposed to be an equals. I don't know where things are going. Square, you get x, dx, easy enough. Antiderivative. Oh my gosh. Come back. X squared over 2 evaluated from 0 to 3. Okay, so we're going to get 9 halves minus 0 over 2. Okay. So pi times 9 halves. 9 pi over 2. Well, 9 pi over 2. I'm going to box it like it's there. Nope, guess it's not coming back. All right, let's take a look at 5. All right, problem 5. Find the volume of the solid formed by revolving y equals 1 over x, this region about the y-axis. So we've got a little change in gears here. I'm going to sketch y equals 1 over x, the reciprocal. I noticed that x equals 2 is going to be over here. And this is the reciprocal 1 over x. Okay, and y equals 2. Okay, it's going to be somewhere about right here. This is y equals 2. And this was x equals 2. And this was y equals 1 over x. Okay, so this bounded region that was formed right here, okay, this is what's going to be revolved around the y-axis. Okay, so what we need to pay attention to is the fact that we're going to have washers, not discs. We're revolving, so we're going to have washers. So put yourself a note. Okay, so we want to show the setup. Pi. We're going to have a, this is with respect to, let's see, this is with respect to y. So we're going to have limits of c and d. Outer radius in terms of y squared minus inner radius in terms of y squared with respect to y. Okay, so what we might want to do is put our rectangle in here, laying on its side. So this is our rectangle that we're going to revolve around the y-axis this way. So that's why we have this gap between the rectangle and the y-axis. All right, I think we're ready to customize our integral. All right, taking a look at our limits here, we need to know what is this y value up to this y value. Well, it's real clear that we can see that the upper limit is going to be 2. Okay, it's just what is this lower y value here. So taking a peek in right here, what we have, this is x equals 2 intersecting with 1 over x. So insert 2 here, so this y has to be a half. So we're finding the intersection of the reciprocal and x equals 2. So this is a half. All right, now we want the outer radius squared and inner radius squared. All right. So we're going to put ourselves on the axis of revolution lined up with the rectangle that's laying on its side. So that puts me about right here. Okay, I'm going to look towards my rectangle. The greatest distance from where I'm standing is to the right. That's my outer radius. The length of that can be found by taking this right side and subtracting this left side. So this is 2. This right x is 2. The left x is 0. So 2 minus 0. Your inner radius, oh my goodness, your inner radius, okay, standing back on the axis of revolution, looking towards the rectangle, your inner radius is going to be the shorter distance here. That's going to be the radius of the hole. So to find this length, to calculate it, if we want to know what that is, it's going to be this equation minus x equals 0. Well, right here, we have the equation solved in terms of x, so we're going to have to solve it in terms of y. So what I'm going to do is I'm going to flip this side and flip this side. So x equals 1 over y. Just reciprocate both sides. So back here, the inner radius is going to be this equation, 1 over y minus 0. I guess while I wasn't looking, it disappeared. 1 over y minus 0. So this is 4 minus 1 over y squared dy. We can certainly find that without a calculator. So 1 over y squared. I'm going to get it ready for integration. Just the second term. The first term's fine. I'm just going to pull this up out of the denominator. Integrating 4y increase to negative 1. Divide by negative 1, so that changes the sign. I don't know. I don't even remember where I was. This is negative 1. This is plus 1. I think this was 4y. I think that was pi. Evaluated from a half to 1. Sorry, half to 2. Okay. Four times 2 is 8. This is really in the denominator, so it's plus a half. Then we're going to have minus 4 times a half is 2. And then 2 plus, and it's going to be 1 over a half, which 1 over a half is going to be 2. All right, and when it's all said and done, you clean everything up, we should get 9 pi over 2. All right, I'm not sure how this one's going to go, but we'll do the best we can. Find the volume of the solid generated by revolving this region about the y-axis. So it's going to be integration with respect to y. Okay, to get an idea of what that looks like, I'm going to kind of come over here. And to graph this, I would square and get x squared equals 1 plus y. Subtract the 1. So hopefully it's on your paper. Y equals x squared minus 1. So I'm trying to draw the parabola x squared minus 1 intersecting with y equals 3 and x equals 0 about the y-axis. Okay, this is bad. So I've got this. I don't know why this is going so bad. This. So originally all my x's were positive x's, so I just want this right branch right here. So what I'm going to do is I'm going to take this region right in here and I'm going to revolve it around the y-axis. So my rectangles have to be in there on the sides. Integration with respect to y, and it's discs. Okay, with respect to y. So my y limits go from -1 up to y equals 3. All right equation. Minus the left x. So this is the right x minus the left x squared. A little bit of cleanup. You're just going to get 1 plus y dy. I'm going to integrate. That's going to go back to y plus y squared over 2. Evaluated from -1 to 3. Three plus 9/2 minus -1. Plug in -1 squared plus 1/2. I think you're getting the idea. Okay, when that's all said and done, you're going to get 8 pi. Well, I guess that's it. The pen's had enough. So hopefully that was a good review of area and volume.